Today, we're diving into something pretty wild, how an AI is learning to drive a car, not from a rulebook, but just by watching hours and hours of video. It's a real game changer, so let's get right into it. So let's just start with the big question, right? How in the world do you teach a machine to navigate our chaotic, unpredictable world from behind the wheel of a car? I mean, think about it. It's one of the toughest nuts for AI to crack.
And this is where we run into what you could call the AI's driving problem. See, there's this weird paradox with modern AI that we've got to unpack before we go any further.
It's this really strange thing, isn't it? We've got AI that can compose beautiful poetry or create stunning works of art, things that feel deeply human. And yet, something that a lot of us do every day, driving, turns out to be one of its greatest challenges. It's like AI is a genius in the digital world, but a total rookie in the real, physical world.
So for a long time, there were basically two ways to go about this. The old way was super tedious. You'd have armies of people manually labeling things in pictures. That's a car, that's a stop sign. You can imagine how slow and expensive that is. But the new way, which is what this S4-driver model is all about, is totally different. It's called self-supervised learning. The AI just watches. It watches tons of raw driving footage with no labels, no instructions. It teaches itself.
All right, so to really get how impressive this is, let's meet our student driver. We're going to start with a totally basic, vanilla AI model, right off the shelf before we do any of the cool stuff to it.
So what is this student? Well, it's what's called a multimodal large language model, or MLM for short. The easiest way to wrap your head around that is to just imagine ChatGPT, but give it eyes. It can understand language, and it can understand pictures, which makes it the perfect starting point for an AI that needs to drive.
Okay, so day one, first driving test. How does our student do? Not so good. You're looking at a chart of its error rate. All you need to know is lower is better, and our vanilla model starts way up here at 0.798. That's our baseline. We've got a lot of room for improvement.
Now for the first, and honestly the most important upgrade, we have to teach our AI to see the world in 3D. It can't just look at a flat picture. It needs to understand space, depth, and distance. This is the difference between just seeing and actually understanding what's going on.
And this right here is the heart of the problem. The AI gets this, a flat image from a camera. But to actually drive, it needs this, a 3D God's eye view of everything around it. So the multi-million-dollar question is, how do you get from one to the other?
The magic trick here is a really clever idea called sparse volume representation. Don't worry about the name. Basically, it's a super efficient way to build that 3D map. It teaches the AI to only focus on the important stuff for driving. Think of it like this. It learns that the car ahead is crucial, but the clouds in the sky, not so much. It filters out the noise.
So did it work? Let's check our report card. Oh yeah, look at that drop. Just by teaching it to see in 3D, the error rate plummets from 0.798 down to 0.728. That is a massive leap forward just from one single change in how it perceives the world.
Okay, that's awesome. Our AI can see in 3D now. But, seeing is only half the battle. You also have to think and make smart decisions. So let's see how they upgraded its brain.
They made two really smart software changes. The first one is called hierarchical planning. It's basically making the AI think before it acts. So first it makes a big picture choice, like I need to slow down, before it works out the nitty-gritty details. The second upgrade is called multi-decoding. Here it imagines a few different ways to handle a situation, and then it kind of votes on the best one. This stops it from taking the easy way out, like just slamming on the brakes for no reason.
And what's the payoff for making it smarter? Let's go back to the chart. Yep, another solid drop. The error score is now down to 0.693. You can see how every one of these logical upgrades is stacking up, making our AI a much, much safer driver.
All right, so we've given our AI 3D vision and a smarter brain. The training wheels are off, now it's time for the final exam. Let's see how the fully upgraded S4-driver handles the real world.
Okay, let's look at some real footage. Here we go. It sees the red light, and boom, it plans a nice, smooth stop. That's driving 101, but it's absolutely critical it gets that right.
Now for something trickier, a U-turn. This isn't just one move, it's a whole sequence. And look, it handles it perfectly. That shows it really understands the space around it and can plan several steps ahead.
And check this out. It's not just a fair weather driver. Here it is, driving at night. The visibility is way worse, but it's still holding its lane, driving safely. This proves it's not just memorizing easy situations. It can adapt.
But okay, how does it do against other AIs? Well, on a standard industry test, the S4-driver actually comes out on top. And get this, it beats models that were trained the old, expensive way with human-labeled data. So it's not just better, it's smarter about how it learns. So what's the secret sauce here? It's one word: scale. Because you don't need people to label everything. You can just throw a mind-boggling amount of data at it. We're talking about a training set that's up to 100 times bigger than the normal ones. It's simple, really. The more it watches, the more it learns.
So this is obviously huge for self-driving cars, but let's take a step back for a second, because the implications here go way beyond just driving.
If you remember one thing from this, let it be this. We have now shown that an AI can learn a really complex physical skill, one with life and death stakes, pretty much just by watching. It doesn't need a textbook that says avoid curbs. It figures out what a curb is by watching millions of videos of cars not hitting them. That's a profound shift in how we can teach machines.
And that brings us to the final big question. If an AI can learn to drive just by watching videos, what else can it learn? Could it watch surgeons and learn how to operate? Could it watch construction workers and learn how to build a house? The era of teaching AI by showing, not just telling, is here, and it's just getting started.